Good morning, good afternoon, good evening, no matter where you are joining us from around the world. Thank you very much for joining our first of our faculty lecture series. This series is done in collaboration between the Office of Graduate Education and our esteemed School of Business. I thank Dr. Michael Muehlen for being here with us today, who is our first lecturer. Dr. Michael Muehlen is a professor of information systems at Stevens Institute of Technology and has been a professor at Stevens since the year 2002, I believe, Dr. Muehlen. At this point in time, Dr. Muehlen's research spans business process innovation, digital transformation of organizations, process analytics, monitoring and controlling, enterprise architecture modeling, and information technology standardization. Dr. Muehlen also serves as the Associate Dean of the School of Business, and this is his second round serving in that capacity. Outside of Stevens, his consulting services span companies such as Barclays, BNY Mellon, Citibank, Credit Suisse, JPMorgan Chase, the Federal Reserve Bank of New York, Goldman Sachs, the U.S. Veterans Administration, U.S. software vendors, U.S. Department of Defense, and the list goes on and on and on. Without any further ado, Dr. Muehlen, the floor is yours. Thank you so much for being here with us today and offering our first lecture.
Thank you very much, Dina. And thank you so much, everybody, for joining from all around the world, East Coast, West Coast, outside of the US. So it's my pleasure to welcome you to the lecture series that the School of Business and the Office of Graduate Admissions are collaboratively hosting. In this lecture series, we have 6 talks every Thursday at 9 a.m. Eastern. So my colleagues and I, we are going to shine a light on the world of business in the age of AI. I will start with a talk on management of AI technologies, and my colleagues are going to continue this. Next week, Violet Chen is going to talk about ethics and responsible AI. And the series is going to continue with topics such as finance, data, and it's going to complete with a talk on AI business models at the conclusion of it. If you attend 4 of the 6 talks, we will give you a LinkedIn badge that you can proudly display. But whether you are here for the badge, whether you are here for the content, we hope this is worthwhile and it gives you a bite of what Stevens has to offer in this particular space. So with that, allow me to share my screen, and I'll get into the topic. We will take questions and comments at the end of the talk in the chat, or you can enter them in the chat as they come up. So I want to begin this story with a story. So a technology company that was well-staffed and well-funded made a couple of decisions a few years ago. They disabled a factory security and safety system because it interfered with the operation of their AI software. They had a human oversight team originally composed of 2 people, but for cost reasons, they reduced that to 1. And they had the ability to monitor operators of this system, but who has the time to do that? So really the monitoring was barely executed. And finally, this system, which was in a prototype phase, they deployed on public roads, in live traffic, and at night. Now, the company made these choices, and individually, each of these choices had a rationale. The safety system created a jerky braking behavior in their autonomous vehicles, so that's why they disabled it. The operator's reduction was a cost move, and dashcam monitoring was available, but nobody flagged reviewing the footage as a priority. Now, that may sound familiar to you, not the specific details, but the pattern, right? We are disabling safeguards because they create friction or people find workarounds. We reduce the amount of oversight because of cost. And we have governance tools, but we're not really using them. So the company in question was Uber's Advanced Technologies Group. They were testing self-driving vehicles in Tempe, Arizona, and this was in 2018. And on March 18th, 2018, one of their vehicles collided with a pedestrian. The car's sensors detected the pedestrian almost 6 seconds before the impact. That's a long time. The system saw her. It classified her as a bicycle at first, and then it reclassified her as an unknown object, and then as a vehicle, and then back to a bicycle. It couldn't decide that it was a person that was jaywalking in an unmarked area of the road pushing a bicycle. Inside the car was a safety driver, and the safety driver was the remaining human safeguard, and that safety driver was watching a television show on their phone. They had been monitoring this autonomous system for 19 minutes, and in these 19 minutes, nothing had gone wrong. So we have an AI system that worked in the sense that the technology detected the pedestrian. The sensors worked. The AI saw her. But the failure that happened was in the human layers around the technology. There was a safety driver who had stopped watching, and a management team that had removed the redundancy. And ultimately, an organization that had the tools to catch these problems that didn't deploy them. The National Transportation Safety Board, in their investigation, called this an inadequate safety culture. But I think this phrase, while it's accurate, is too gentle. What happened in Tempe was a normal accident. Charles Perrow wrote a book about that in 1984. And normal accidents aren't called normal accidents because they are acceptable. They're called normal accidents because they are inevitable if you build a complex system of human and machine and you don't build in the slack to mitigate unforeseen consequences. So this could have been foreseen. Now, what I want to focus on in this talk is a question of the design between AI and humans. And while the story that I start with is alarming, I don't want you to mistake me for a pessimist, right? I'm not a technology pessimist, quite the opposite. I'm an optimist by nature. I think AI is going to do great things, both for businesses, for individuals, and for society. But I do think that we need to be careful in how we think about this technology and how we design the technology in its deployment in our organizations, in our government agencies, and in our individual lives. So often when we talk about AI, what we talk about is, what can it do? How can we make it more efficient? How can we make it more transparent? We are trying to design AI around the workflows, around the processes that we have in business. But I think that's the wrong question. I think the question should be, how do we design the human to work with the AI? Because once you put an AI in an organization, you've already changed the nature of work. You've changed the workflows. You've changed the decision-making structures. You've changed how the human interacts with the technology. And rather than keeping this a technology question to be debated by technologists and to be answered by technologists, it needs to be a question of integration and of human design. And the question, where does the human add the most value to the system and benefit the most from AI? So that's what I want to talk about this morning. Now, to begin with, let's start with one thing. AI is not new, and AI is not one thing. AI is really an umbrella term for a whole host of technologies. Some of them you interact with on a daily basis. Every time you unlock your phone with your face, there's an AI that does facial recognition. When you use natural language processing to summarize a document, you use AI. When you have a camera on a manufacturing line that detects defects in circuit boards, that's AI. Right? So AI is a lot of things. It's not just ChatGPT or Claude or Gemini. It is a whole host of technologies. And each of these technologies behaves in a particular way, is trained on a certain set of data, and can fail in its own unique ways. So rather than say in a situation we should use AI for this, a better phrasing would be, what kind of AI would be appropriate for this situation? That in itself will improve the quality of the conversation. The next thing I would say is AI is like water in two different ways. So one, it finds every nook and cranny of the organization. You don't have to invite AI into your business. The AI is already there, whether you've written a strategy document about it or not. There is somebody who built an agent last weekend. There's somebody who's using ChatGPT to rephrase an email. The marketing department is working on ad copy using AI. Somewhere there's a machine learning algorithm that is being trained on your data. So the AI is already in the organization. It didn't wait for an invitation. That's one thing. It's like water seeps in everywhere. The other thing that you should keep an eye out for is that, like water, AI lifts boats. And AI, in particular, generative AI, can lift the performance of individual operators in your organization. But it doesn't lift everybody the same way. Researchers have found that while high performers benefit from the use of AI, average performers benefit even more, and low performers perform even more. So the performance band in your organization is going to get compressed and elevated at the same time. So that's a good thing, but it brings with it organizational questions. Like, how do you value expertise? If somebody who's mid-career, who has a very deep expertise in a particular area, are they worried that the AI is going to do what used to be their secret sauce for a long time? You have to think about the human consequences of that. The third thing I want to say is that the adoption of AI in your organization is uneven. William Gibson famously said, "The future is already here, it's just not evenly distributed." And that's the case for AI. You've got parts of the organization that are very AI forward. There are people that are building machine learning algorithms for credit scoring or similar applications. But there are other parts of the organization that are debating whether ChatGPT should be allowed or not, or whether you are using maybe not a frontier model, but a more moderate model of AI because it has organizational safeguards around it. So this unevenness is expected because different disciplines and different people look at AI through different lenses, but the difference in adoption speed should be deliberate, right? Fast movers may be right and slow movers may be right. They all have their own reasons. It's for the manager to decide in which areas you can move faster than others. Now, the realistic ceiling of AI capabilities is not yet established. So you may be familiar with the hype cycle that Gartner publishes every once in a while. It says every technology that comes out of labs starts with an innovation trigger, an invention of sorts. And then we go to an area that's called the peak of inflated expectations, where we think it's going to cure cancer and solve all the problems of the world. And then we find out that the technology doesn't do that. So we drop into this trough of disillusionment. And then after a while, technology then moves slightly up through a slope of enlightenment where we learn how to use it productively and we end up in this plateau of productivity. So where does AI fit on this hype cycle? Well, I can confidently say that you are here. But you're also here, and you're here, and also there. Because there are different AI technologies and they are at different phases of the hype cycle. If you're talking about machine vision, quality control through vision AI, that's already there. It's established, it's implemented, it's boring at this point, right? But when we talk about multi-agent systems that collaborate and solve business problems, we're on the way to the peak of inflated expectations. When we talk about AI-supported coding, things like OpenAI's Codex or Anthropic's Claude Code, we're probably just past the peak of inflated expectations. We had a lot of feedback that people said, I don't need to study computer science or software engineering anymore. The AI is going to write code. Yes, it does. But it writes code like a really enthusiastic intern, not like an experienced software engineer. So we're learning, and I think we will learn what the capability ceiling of these systems is. And Gartner placed generative AI last year near the trough of disillusionment. I'm a little bit more optimistic than that. So when we manage AI in an organization, we have to think about where on this hype cycle it is, where people think it can go, and what our realistic performance expectations can be. Now, one thing I want to give you as a practical framework is called Sheridan's scale of automation. So Sheridan and Verplank wrote a paper in 1978 and said there are 10 levels of automation between a system and a human that you can think of, where at level 1, it's all manual. There's no help to the human by the system. And at level 10, the system does everything. It automates everything. So in the lower levels here, the computer either offers no assistance or gives you a set of options or might give you a default options or even suggest you one alternative. But the human is in control. The human has authority about what happens. You decide whether you click or not at this level. It's at the next levels up where it gets a little murky. So there we have the transition zone between where the human authority ends and the machine authority starts. So it could be that the computer says, I need to install an upgrade. Please click OK. So that might happen. Or it could be that the computer says, I will reboot within 3 minutes unless you click this cancel button. Right? So the computer has more authority. Or the computer will execute and then will tell you what it did when your computer crashed and said, I had to restart because of a problem, and there was no human intervention, right? That's the difference between asking, may I please do this, and saying, I just did this, here's the receipt. So this is the transition zone. And then, of course, there is the zone of machine autonomy, where the computer does things and tells you about them, or tells you if you ask them, or just does it and doesn't even tell you. There's nothing right or wrong with these different levels of autonomy in this automation scale. There are applications that are well placed at the lower levels of autonomy. If you use Claude Copilot or Microsoft Copilot, or you use something like Claude Cowork, you're typically at level 5 or so. You have a system that will execute something, but you have to give it the authority to do so. You have to click OK. When we talk about autonomous systems, then we're talking about systems at level 8, 9, or 10. So the Waymo robo-taxis that drive autonomously, they are at those levels. So make a distinction between an agentic system and an autonomous system, right? Agentic AI is not automatically autonomous AI. Now, there are two ways how we can deploy AI. Now, one way would be that we put AI in the workflow. The AI does the work. And when the AI does the work, then we can place it at different levels of autonomy. So it's either a system that helps you, it suggests things, or it could be a system that executes with your approval, or it could be a system that automatically prevents a process from happening. So every time you swipe your credit card, there's a little algorithm that runs to decide whether that transaction was fraudulent or not. And if it was flagged with a certain degree of confidence that it was fraudulent, then we would let the system automatically block this. There's no human intervention. There's no, oh, this transaction looks fraudulent. Do you want to block it? The system at that level is autonomous. It sits in the workflow. It performs one step in the workflow. And it's very likely that we're going to have lots of AI systems that we plug in to perform certain tasks, whether it's summarizing a document, reading an image like an X-ray or an MRI, and flagging that. That is AI in the loop. AI does the work alongside the human. The other deployment posture is AI on the loop. So AI on the loop means the AI will watch the work, it will supervise the work, it monitors, and it looks for drift, where a system might go out of kilter. So at level 4, That's your typical dashboard. It sees something, it recommends something, but it waits for you to do something. At level 7, the system would adjust certain parameters, maybe on a manufacturing line, and log what it did. And at level 8 and above, this would be completely autonomous. So I want to talk about these two deployment postures, AI in the loop and AI on the loop, and I want to give you some examples of firms that have done this. Let's start with JPMorgan. So in 2017, reports came out that JPMorgan had developed a natural language processing system called contract intelligence, or COIN for short. So for commercial contracts, there are lots of legal documents that need to be reviewed. Typically, lawyers do this. Typically, lawyers hate this. So they built a system that used natural language processing to read through these contracts, to identify clauses and their positions in the contract. And they would either classify the contract as okay, or they would flag anomalies. And then there would be a human exception review before a decision on the contract would be made. It was a massive productivity improvement. So contracts that used to take lawyers a cumulative 360,000 hours were reviewed by the system in minutes, and the error rate in the contract review dropped by factor 10. But what I want you to pay attention to is this design choice that they made. So they had the system read the contracts, flag the contracts, process the contracts, but there's still a human in the loop here. There's a human exception review. So the AI is in the loop as a step in the workflow, and the human is in the loop right after the AI to review the output and ultimately then make the decision. Now, human in the loop sounds good, but human in the loop can fail. Because when you have a human review, you have to ask, is this review substantive or is this review theater? Do we just go through the motions, but we're getting complacent? Right? And there are two reasons for that. One is called automation bias. So studies have shown that when you get a recommendation from an AI, humans tend to agree with it. And even if you give them additional information, such as an explanation why the AI came up with the recommendation, humans still agree with it more than they should. Yeah? So that is automation bias. We trust the AI too much. Part of this can be attributed to human nature. So if you sit in this loan process and the AI says you should not underwrite the loan, and you override the AI and the loan goes bad, then that's on you. If the AI says you should underwrite the loan and you agree with the AI and the loan goes bad, then that's on the AI. So if you override the AI, there's an asymmetric risk that you're going to be blamed for it. So human nature, it's better to agree with the AI because if anything goes wrong, it was the AI's fault. It wasn't your fault. So the most protective factor for this automation bias is not training people how to use the system. It's not reinforcement. It is deep expertise and effort. So you have to ask the reviewer maybe to come up with an independent judgment and then show them what the AI recommends and then reconcile if there are any differences. Right? Have the AI make a recommendation, have the human make a recommendation, compare the two. If they agree, you proceed. If they diverge, then you go to an escalated review stage. The other thing that is risky here is that the people that develop a system and the people that use a system sometimes don't have the same perspective on it. So Amazon developed a resume screening system in the 20-teens that would flag or score resumes of applicants on a scale from 1 to 5. And they used the resumes of their current staff as training data. They say, these are the people that work at Amazon. These are the people that we want at Amazon. Use this as a guideline to determine what a good resume looks like. Well, it turned out that that resume screening algorithm gave lower scores to women and to graduates from women's only colleges, because the workforce of Amazon had skewed male engineering and they had historically hired fewer women. From the machine learning engineer's perspective, that was perfectly all right because the system reflected the training data, right? It basically acted the way it was trained. But of course, the HR department and the legal department were not happy with that. They had a different perspective of what the difference between correctness and fairness in the system was. So when you have a review, make sure that the right people review it, and that can be a multitude of people. Now, if you need these governance layers, here's a good example of how you can structure this. This is from the Mayo Clinic. So in the Mayo Clinic, there is an AI in the loop that looks at MRI scans. So these MRI scans are image scans. They get segmented by the AI, and the AI then starts flagging anomalies and gives a suggestion that gets reviewed by a radiologist. The radiologist can agree or disagree with the AI, can change the AI's annotations, can override them. And what the radiologist determines is final. So there's the human review in the loop, and it's the radiologist's word that ultimately goes back to the clinician and goes back into the treatment of the patient. On top of this, they have a performance tracking. That's where they have an on-the-loop system. And this on-the-loop system looks at how often the radiologist and the AI agree or disagree. So if the radiologists continually override the recommendations of the AI, that may be an indication that the algorithm isn't very good or that it has drifted over time. If the rate with which radiologists agree with the AI goes up, it could indicate that there's this reviewer fatigue or the computer automation bias at place. And so that would have to be then corrected, maybe by introducing some training images and red herrings into the radiologist workflow. So that's the second layer that sits on top of the workflow. The third layer that they have, and that's an FDA requirement, is they have a review board for software as a medical device. And so AI is classified as software as a medical device. And this board is independent of this loop and has the authority to decide which AI gets deployed, which AI gets pulled, and what the quality standards are. So multiple layers of governance. So Mayo Clinic last year, actually the year before last, published a paper on this deployment. And one of their insights was that solving the technology bit is easy, but getting the governance right and getting the right parties on board, that was the important thing that they had to solve. And they identified in Mayo 4 distinct roles that they were talking about. They had the technologists that build the algorithm. They had the translators that integrate it into the clinical workflow. They were talking about the users that sit in the review step. And they were talking about governors, the oversight board, the software as a medical device board. Important roles that you need to think about. And I'm going to pick up some of these roles a little bit later on. Now, it's not like in the Uber case, we didn't have governance. We had a safety driver, we had monitoring, but these layers were systematically dismantled or not used. So you can have governance layers on paper, but you need to make sure that they are actually alive and being acted on. Now, the final deployment that I want to show you is from Meta, the parent company of Facebook. So in 2017, 2018, thereabouts, Meta published an algorithm called Prophet, a machine learning system that can forecast time series data. So an example that they give in their paper is, how often do people look up a famous football player on their Wikipedia page? There's a certain seasonal trend. The football season runs in the United States from the fall to February or so. And clearly in May, June, July, August, there are fewer clicks on that page. But at the beginning of the season, it goes up. And then by the time the final game, the Super Bowl, comes around, this spikes up. This system is able to predict these types of demand curves or these type of interaction curves based on seasonal data. Meta uses it to forecast revenue. Because it's a completely digital company, right? They serve ads on Instagram and on Facebook, and every time you click, money changes hands. They can forecast their revenue on a minute-by-minute basis using this tool. So the profit algorithm gives them a forecast of the revenue and compares that to the actual revenue that is being received. And when there is a divergence, when the actual revenue diverges from the forecasted revenue, then nothing happens automatically, but a human is alerted. And this human then performs an expert analysis. Why did the revenue diverge? The system said that it did, but it can't really tell why. That's the expert's role. And it could be for 3 different reasons. It could be because something broke. A server went down, there's an internet outage somewhere, particular ads weren't being served. So that's why there's a divergence. Or it could be that everything's okay inside the company, but the world changed. There's a competitor that came out with a better product, or there is an event like the Super Bowl that changes user behavior, and that might require a managerial response. Or it could be that the model is wrong. It could be that the algorithm has not been trained on the correct data, and in those cases, they might roll it back a snapshot or two. This algorithm is retrained multiple times a day for accurate forecasting. So it's an AI on the loop system because it's not in the algorithm that serves ads. It's not in the workflow that creates value for the customer. It's a supervisory algorithm. It's AI on the loop here, but it still relies on the expert. So I want to bring this back to this model of 10 layers of automation. And in these 10 layers of automation, it's not a single dial that you turn. It's actually 4 dials. You can think about an AI workflow or a step in an AI workflow as 4 discrete steps. You can think about the acquisition of information. How do you get the data? You can think about the analysis of data. That's where the machine learning algorithm produces its predictions, its classifications. That's where your large language model might analyze the context and produce an output. Then there is a decision to be made because we're not using systems just because. We're using systems because we want to decide something or do something. So there's the decision of what should happen next. And then there's the execution, the action of what should happen next. For each of these 4 steps, you can choose your level of autonomy, your level of automation. And so for data acquisition and data analysis, it's okay to have a very high level of autonomy. You want this to happen quickly. You want this to happen automatically. But for the decision making, sometimes you want to deliberately slow down. And you want to deliberately choose a lower level of autonomy where the human is in control to make the decision. And then depending on what the action is, you could have low automation for the action, or you could have high automation for the action, depending on your scenario. But the message here is that you want to send these dials deliberately. If you move the decision automation up very high, a couple of things will predictably happen. One, people that used to make the decision will lose the situational awareness because you can no longer see how the data leads to a particular decision, leads to an outcome. So your visibility decreases. People become complacent because the computer decides it. And ultimately, these skills will atrophy. If something goes wrong, who is still in a position to manually make this decision or to manually override what the computer says? That skill begins to leave the door as soon as you fully automate that. So you want to be really careful about automating that decision step. So what are 4 things that we can now do when we have known consequences of a process that are of various levels of severity? So number 1, think about these dials independently. Can you automate the acquisition of data? Does it come from sensors, from Internet of Things? Does it come from databases? Where does your data come from? The analysis of data, you want to have maybe a machine learning algorithm or a natural language processing algorithm that crunches through the data. Is it properly trained? So to bring this back to the Uber case, the data acquisition worked. The car had a LiDAR system, it had a radar system, it had a camera. It acquired imagery of the road ahead. For the analysis, though, it was missing training data. It hadn't been trained on jaywalking pedestrians. So there was a gap there. And you need to keep in mind when you have an algorithm for analysis that it's been properly trained. The second thing you want to do is you want to build in slack. So Perrow in his 84 book said complex systems that have no slack will ultimately lead to normal accidents. And that slack can take different forms. It could be human slack. It could be you require an approval step. Or it could be a temporal slack where you just delay an action for a reasonable amount of time to allow somebody to intervene. And then there's institutional slack, and that's what the Mayo Clinic has. They built their software as a medical device governance board. That is the institutional slack that has the ability to prevent bad things from happening. Third step, design for the actual human. The person that is monitoring a system, that's staring at a screen for 8 hours a day and is beginning to fatigue, is beginning to agree with the AI, is showing signs of cognitive drift here. So you want to design for the actual human, and you may want to build in functions that require expertise and that require effort in order to keep the human sharp. Monitor the monitors, like the old Dr. Seuss book. And finally, you have to think about the reversibility of actions. If you send out a wrong marketing email, it's not good, but the consequences are relatively minor. But if you have a car where the automatic brakes are disabled, right? If you have financial guidance that goes out with your quarterly report, the consequences are significant. And so you want to make sure that you have a buffer where a decision is reversible before these consequences ensue. If the stakes are low, automate away. If the stakes are high, be very deliberate about where you build in the buffer. So that brings me back to these different roles and what organizations do. So at Stevens, we teach a lot of management of AI. We have a certificate series. We have a master's of business analytics and AI. And we work a lot with corporations. And what we've learned is that people have different roles when they interact with AI. There are the technologists, the developers. They build the algorithms. They study machine learning. They study data science. They study computer science. They have deep technical expertise of how neural networks work, of how random forests work. So you need these people to build the solutions. But you also need the curators, the people that look after the data. Machine learning algorithms, natural language processing systems, large language models, they are all trained on large amounts of data. The data has to come from somewhere. You need to make sure that it's balanced, that it's unbiased, that it reflects the reality that you want to train on. So we need people with data expertise. And my colleague Aleksi Aaltonen is going to give a talk in the series specifically on AI and data in a couple of weeks. Then we have the translators, the integrators, the people that plug the AI into the workflow. And what is maybe surprising is that the way AI is being talked about is as if every single one of us is building an AI system. And I assure you, you're not. Most of you are not. Most of you are using an AI system that somebody else built, whether it was OpenAI or Anthropic or Meta or Google. Or even Mistral. You are in most cases not building the system. You are integrating an existing system that has entered your company. And it may have entered because an employee built a shadow AI system that worked, or it has entered because a vendor has introduced an AI upgrade in their software stack that wasn't even reviewed, and it just entered through the latest software update that your IT department rolled out. So often you're a user of an existing system, but you need to figure out how to integrate it into your workflows. And then, of course, you have the governance and management layer of saying, how do we oversee these initiatives? Where does the human fit into the system? How do we build the governance layers around it? 4 different roles, 4 different requirements. And many organizations tend to invest in the developers and maybe a bit into the curators, and they hope that the rest of them sort themselves out or kind of figure it out as they go along. And kind of figuring it out is not a good business strategy. Katja Megjoren is going to talk about AI business models, and I hope she's going to talk a little bit about strategy as well in the last talk in this series. But my point is that if you want a successful AI deployment, don't just invest in the technologist, you need to invest in the integrators and you need to think about governance. So let me bring this home back to the Uber case. If you compare a highly automated AI on-the-loop system like Meta's Prophet deployment to the Uber case, you see that in the data acquisition, both systems were at a high level of autonomy. And the data acquisition in Uber's case worked. The sensors worked. They detected an obstacle on the road. They couldn't just not figure out what it was, but they saw it 6 seconds before the accident. In the analysis phase, the Meta system gives you an alert when real revenue and forecasted revenue drift. In the Uber case, the system detected something, but it was lacking training data. It didn't have training data on jaywalking pedestrians. So there was a data gap there. When it came to the decision, in the Meta case, it's a human decision. What happened? What should we do? In the Uber case, there was a safety driver in the car. The system was designed for the human to take over if the AI ran into trouble. But what had happened was this operator fatigue. Nothing had happened for a long time, so the attention was on the phone rather than the road ahead. So it was designed for an autonomy level 4 to 5, but in practice it was like an autonomy level 7 because the operator just didn't pay attention. There was a drift, and this drift isn't by design, this drift is by default. It's natural that this happens. And then in the action phase, in Meta's case, it's manual action. In Uber's case, it would have been fully automated action. The car that they used was a Volvo. Volvos have an extremely high safety record. They're very safe cars. They have an automated braking system if a pedestrian is in the vicinity of the car. But the engineers had disabled that because it wasn't compatible with their software. Had that been in place, the consequences might have been mitigated. So, human in the loop by design in Meta's case, and human out of the loop by default in Uber's case. So I want to leave you with these thoughts, right? Let's recap. AI is not one thing. It's a collection of technologies, and each have different capabilities and failure modes. Number 2, it's already there. It's inside your organization. It didn't wait to be invited. It invited itself, right? We also don't know what the realistic ceiling is of what it can do. Anybody who tells you otherwise is trying to sell you something, right? So in this environment, the question is not what can AI do? The question is, where does the human belong in your AI? And you want to make this decision deliberately. If you don't set each of these 4 automation dials based on what's at stake, what the consequences are, and if you don't build in Slack into a tightly coupled system, if you don't design for the psychology of actual humans, and if you don't staff the translation layer and the management layer of the stack, then you're inviting normal accidents to happen. And we don't want normal accidents. We want AI to be safe and we want AI to be productive. And I'm sure AI is going to do great things in the future, but we need to make the decisions around where the human belongs. If you don't make this decision, somebody else is going to make the decision for you. Our dean always says, if you don't make a plan will be made for you. But who makes that plan? It might be a vendor that does it. It might be an employee that built an algorithm over the weekend, or it could be a competitor. Or it could be an algorithm in a car in Tempe, Arizona at 9:58 at night. So the technology is here. The question is whether you designed the human architecture around the technology or whether you just let it happen. That's the question for you to answer and to research. So I hope that this was useful for you. I want to thank you very, very much for joining this morning. And I can see that we have some comments in the chat. So I'm going to hand it back to Dina to moderate a bit here. Thank you very much. That's a great question, and I would have to go back to the NTSB report to look at the specific recommendation in that case. Uber originally had two safety drivers in the car, so reducing that to one driver was seen as already as a step that led to this. You have nobody monitoring the monitor in real time. The other thing would be, of course, to remove distractions from the car itself, meaning they had this dash cam. On the dash cam, you could see that the safety driver was looking at the phone that was in the middle console and was watching a TV show. So removing that would be a step forward. There are cars with autonomous driving modes that require you to put your hands on the wheel in regular intervals. And if you don't do that, then the car is going to go out of the autonomous driving mode. So that's the other thing, where you deliberately lower the level of autonomy if you find that the operator is being distracted. So I guess what I'm arguing for is that there are situations where you want a zero-touch process, where you want technology to be autonomous. If I had a pacemaker, right, I wouldn't want my pacemaker to be at a low level of autonomy. I wouldn't want it to say, hey, you seem to be having a heart attack. Would you like me to administer an electric shock? Please click here for yes or for no, right? That's an application where full autonomy is absolutely warranted. But that's where it has been tested, and the consequences of not being autonomous, the consequence of delaying an action, are so severe that the autonomy is warranted. But there are other situations where the consequences of an action are unrecoverable from. So I'm not saying that the action shouldn't be autonomous, but the decision to take the action, you may want the decision to be manual at a lower level of autonomy, because you want to have that circuit breaker in place where you can mitigate before something leaves the door. Right? Every complex system failure, when Perrow wrote his book, it was about nuclear technology, it was oil refineries, it was other types of complex system. Every time of complex system failure or meltdown is typically a confluence of multiple things that have gone wrong. It's not just that the operator was distracted, but if the operator hadn't been distracted, that accident could have been avoided. If the safety braking in the car hadn't been disabled, the accident, maybe the accident wasn't avoided, but the severity of the accident would have been less. If there was monitoring in place, if people had reviewed the dashcam footage to see how attentive the safety drivers were, if that was a regular instance, maybe they would have taken steps to increase the alertness, found ways to do that. So there are systems where it's totally acceptable for the system to be autonomous. You have to think about what the consequences are, where the decision takes place, and who is taking the action or how the action is being taken. Right? My argument is not that humans should do everything. My argument is you need to be deliberate about each of these four dials: data acquisition, data analysis, decision making, and action. I think, again, I would think about what are the consequences and what's the output of the process. You can have a human in the loop and ask them to review every single instance of a decision, or you can have the AI develop a prediction with a confidence level, and you have a certain threshold where you say, okay, if it's below a certain confidence level, then I'm going to go into a human review. But if you're absolutely sure, then we're going to automate it, and maybe then have the second layer loop on top of it that says, is the split between the human review and the fully automated execution staying consistent, or are we automating more and more, or are we reviewing more and more? So that's where the AI on the loop comes in to monitor the performance of the system. It's similar to triage in an emergency room, really, where you're trying to assess early on how much effort you're going to spend on an individual case. Like anybody who has a little child or had a little child at some point may have had a trip to the emergency room, and the first time that happens, the first time it happened to me, the nurse was like, "Oh, your child is crying. She's fine." It's the ones that are not crying that we're worried about. That's a very rough triage, but they say, well, if she's crying, she's breathing. If she's breathing, that's already a good sign. The ones that are quiet, they do need more attention. So the question is, where does the decision to triage sit? And on what data do you make the decision to triage? Do you put something into the human review as opposed to like a fully automated path? So introducing Slack can take different forms, right? Slack can be, um, as I said, putting the human in the loop to make the decision. Slack can mean that we put in a certain cooling off period before a send occurs. So to give you a very concrete example, here at Stevens, in Mrs. Caro's office, we receive graduate applications for our programs. They are reviewed and they are adjudicated, and a reviewer from a department might say, yes, I want to admit that candidate, or no, I don't want to admit that particular candidate. We could immediately send out the decision, but we don't do that. We actually delay sending out these decisions by a couple of hours up to a couple of days, because we know that sometimes the reviewer has a second thought and said, oh, I do want to offer an additional scholarship to this particular candidate, or I need to take a second look at a candidate who I initially thought wasn't qualified, but on second thought, maybe I should change that decision. So there is no mandatory human review between the decision making from the academic side and the sending out of the decision, but there's a time buffer built in order to reverse the decision before it leaves the house. That's another form of Slack. And the third form of Slack is simply to have this governance layer on top that is continually reviewing the system, and that is creating the organizational friction that forces developers to argue why their algorithm works, or why the system is still performing as advertised. So Slack can take different forms. It can take human form, it can take time form, it can take the organizational friction form. I think that's an excellent question. And this basically goes to the point of shadow IT systems. Like when I was consulting on Wall Street, we had one firm that had 2,000 systems in their operations division that were not sanctioned by the central IT division, that had just popped up overnight or built by summer interns, or somebody wrote an Excel macro, somebody knew how to use Python. And in many cases, the affected departments were quite afraid to turn these systems off because they didn't quite know how they were wired into the existing workflows. Now, so I'm going to answer your question in two parts. One part is, how do you find out what's happening? Where there are techniques such as process mining that take digital traces of the work that's being done in the organization and that reconstruct a process map from these digital traces. If you have an idea of what's supposed to happen, you sort of have a reference process, and then you can take the discovered process and overlay it and see where are workarounds happening, where are steps being skipped, or where are additional steps happening. That would be very much looking at the structure of the process. The other thing, if you wanted a higher level signal, is you're looking at how long things take, how long have they taken historically, and where are they trending. So if you have a task that used to take 2 weeks, and now it's being completed within half an hour, either your organization all of a sudden has extremely good performers, or they're doping with AI. So they're using large language models to write their emails, etc. So monitoring and mining are techniques that we can use in this space. In terms of how do we train people that are not industrial engineers to critically reflect on the output that the AI systems generate, I think education in terms of how these systems work is an important component of that. So, and the other thing is that the technology is getting better. We have, uh, I think about a year and a half ago, we thought that prompt engineer would be the job of the future for a large language model. So people that frame a request to a large language model in such a way that it includes enough context for the system to create a reasonable output. But reality has completely overtaken that, in that most of the frontier model, whether you're talking about ChatGPT, Claude, or Gemini, they use retrieval augmented generation. So you ask a question, it goes out to the web, it gets some additional information. It may go to your local database and get additional information, and it has a much more comprehensive context of your question before it generates an output. So I think A, the systems are getting better, and B, the thing is that we just need to keep educating the users on what these systems can do reliably, right? Most AI systems are sophisticated prediction machines with certain degrees of confidence built in to the generation of the output. They are not systems that really understand reasoning, and that's why when you generated images with early versions of things like Midjourney, people had 6 fingers on a hand or 2 left thumbs because they didn't have enough training data on these types of things. So I would say monitoring, mining, and education are the two steps there. But it's a great question, Peter. I think that's a fantastic comment. Thank you, Tom. The um, the first time I used an agentic AI coding tool, I was deeply impressed at how well it could write Python code that I couldn't write myself. When I then tried out the code, I found that it's not quite doing what I wanted it to do, and I had to go and ask it to revise certain things. Now, I never formally learned Python. I learned COBOL, C, Ada, Pascal when I was an undergraduate student. I don't use any of these languages. But the more programming languages you learn, the better a programmer you become, because you understand the more abstract concepts, right? And that's the point. If you become a computer scientist or a software engineer, you learn a particular way of problem solving, of decomposing a larger problem into smaller units until you end up at a level where you can reliably solve them or have an approach to solve them. And then the technology that will help you solve it might be AI based. It may be a large language model, but the framing of the problem and the understanding of what you want is continue to be important. So I do agree that we do want computer scientists, and we do want software engineers and industrial engineers. Those are really important skills. And the humanities with the critical thinking skills, I do think that they will increase in importance, in particular when it comes to the ethical question of, should I even use AI in this particular context? And I do want to put in just a little plug here for the talk next week that my colleague Violet Chen is going to hold on Foundations on Ethics and Algorithmic Fairness, where we're going to talk about the ethics of AI. So Tom, I know this wasn't intentional, but it was a nice idea to throw it over to that. So I think we will not have seen the last computer scientist graduate, and we will not have seen the last industrial engineer graduate, because the skills of problem decomposition, problem solving are going to remain important. And after all, if the AI is going to do everything, who's going to develop the next generation of AI tools? We're not at the level of Skynet yet, where these tools write themselves. So we had a couple of questions in the chat that unfortunately we did not have the opportunity to answer while we were on air for the presentation. So I'm taking the opportunity now to answer these questions for you. If you're still watching at this point, this is something that you didn't get in the live lecture. We're not at one level of the Sheridan scale. We're at all of them simultaneously. And that's the point of showing you the hype cycle slide, to say that AI technologies are at different levels of maturity and different levels of autonomy at the same time. If you have an email spam filter that operates at level 9 or 10 and has for years, But the radiology AI at the Mayo Clinic is at level 4. It suggests a finding and then the doctor decides. So the scale or these levels, it's not something that humanity climbs in order to achieve full autonomy. It just means that it's a set of design choices that you can pick for your system depending on what's appropriate. So level 5 isn't inherently dangerous. It means the computer executes if the human approves. So if you go into a store and you use Apple Pay or Google Pay and your phone asks you for your Face ID before the purchase is completed, it's exactly that. The computer will authorize the credit card if you approve it. But the problem arises when we design a system to be at that level and then we let it drift because we stop paying attention, and it was designed for something like level 5, but it acts as if it's at level 8 because we just blindly approve everything that it puts in front of us. And that's the Uber lesson, right? It's not the threat that the technology will reach a danger zone. It's the threat that we stop paying attention and we have a system that de facto is in the autonomy zone, where while it was designed for human oversight, while it was designed for a lower level autonomy. Trust calibration means that we make sure that our confidence in the AI matches how reliable the AI actually is. If we have too much trust, that leads to automation bias. And if we have too little trust, then we will ignore AI output even though it's valuable, and we lose the performance benefit. So the first approach to this would be to communicate how much uncertainty there is in the system. A system that says, I'm 92% confident that this answer is right, or I'm 92% confident this item belongs to category A, that's a system that performs better than a system that says, this is category A, without giving you the level of confidence that it has in this judgment. If you look at confidence scores, people can decide for their own which score makes them uneasy as opposed to which level they trust. The second is you need to create experiences with failures, right? If a system is 98% reliable, that means that you very rarely see an instance where the system is wrong. And if you don't see the system being wrong, you'll stop checking. So some organizations will deliberately include cases where the AI is known to be wrong, so the human stays vigilant. It's similar to an airport screening checkpoint where every once in a while a computer-generated image is inserted into the screener's screen so that they flag a suitcase for maybe something that looks like a weapon. The suitcase isn't there in reality, but the image is inserted to make sure that the screener stays vigilant. And then there's the question of what your trust environment looks like, and you should pick a Sheridan level that's appropriate to that. So if you have a new system, you should probably start at a lower level of the Sheridan scale. The system suggests an alternative or the system asks for your approval, and you should only increase automation once the trust is empirically justified, once it's clear that the system works. Don't start with a fully autonomous system and hope that people are going to exercise oversight over it. So if the human isn't skilled at decision making, how do they deal with the output? That's why I was talking about this design principle to say design for the actual human, not the ideal expert, but the person that's actually sitting in front of the system. If the human reviewer doesn't have domain expertise, the deep expertise, the human in the loop becomes more of a theater performance than an actual safeguarding step. The people that do the review, they do need the expertise to either do it themselves if the system fails, or understand when the system is right and when the system is wrong. The organizational response is different from the decision function. The person that reviews the AI output needs the domain expertise about whatever the AI is deciding. But the people that sit on the loop, that monitor the performance of the AI system, need to understand the domain as well as concepts of machine learning drift, reliability, and associated factors that determine whether an AI system is actually reliable or good. So you need one expertise. If you're in the loop, you need an additional or a specialized expertise if you're on the loop about how AI systems work. So how do we detect model drift or unintended consequences? How do we make it auditable? So there are two case studies that I used in the talk. Meta Profit, which measures continuously and compares predicted output against actual outcomes. If they diverge, there's an alert that's being raised. It's statistical monitoring, if you will. You're watching for shifts in the distribution, in the model's accuracy over time. In Mayo's example, we have the layer 2, the performance tracking, which looks at the AI output and the human output and whether they agree or disagree. And percentage shifts there may indicate that the AI is getting worse or that the human is getting complacent. Is this auditable? It should be, and some regulators require that. So for instance, the EU AI Act mandates documentation and monitoring for high-risk AI systems. And in healthcare, the FDA has this software as a medical device framework that has ongoing performance monitoring requirements. There are a couple of practical tools that companies use. There's shadow scoring. So the human makes a decision, the system makes a decision, you compare the output. Or you keep some cases back that the system does not evaluate for human-only review. So you split your review set into an A-B set, one for the system and one for the human. And there's statistical process control and other things that you can learn in your industrial engineering classes and in your operations management classes. Our Six Sigma experts in the audience will be thrilled by this. How do we use AI in the loop to monitor model performance and quality? Well, you can use AI to monitor AI, and in production machine learning systems, that is increasingly common. So you have one model that makes a prediction or a decision in a workflow, and the second system watches the output of the first system for anomalies, shifts in inputs, degradation in accuracy, changes in latency, and so on. Meta Profit is a very clean example of this. The forecasting model runs automatically. The monitoring layer compares predicted versus actual revenue automatically. If there's a divergence, then it gets flagged for human review. There are tools like Evidently, YLabs, and Ares that provide automated drift detection. So there are commercial offerings in this space as well. They look at the importance of features and they create alerts. But the design principle is still the same. You need a monitoring system that tells you that something changed, but you need an expert to understand why it changed or what to do about it. If AI gets into the organization stealthily, either via people using ChatGPT on the weekend or via vendors that upgrade their system, that's one of these problems that I mentioned as AI is like water. AI arrives embedded in your CRM system or in your human resource system or your accounting software. Nobody really made the decision deliberately to deploy it in those spaces. It just came as a feature update from the vendor. And you should treat this like you would treat any third-party risk. First, create an inventory. Where do you have AI components, either embedded, integrated, built as shadow IT? So create an inventory so you know where it is. Then classify it by the consequences. What would be the worst outcome if the system was wrong? So is it a bad meeting summary, which is one kind of problem, or is it a biased hiring recommendation, which is a different type of problem, right? You want to look at how reversible these decisions are to figure out what to do about them and how much slack and oversight you need. So you inventorize, you classify by consequence, and then the third aspect that's really important is you assign ownership. Where does the ownership of these AI systems sit? And how much knowledge of the AI component and training on how to measure the quality and oversee the system do the people that have the ownership occupy? So in other words, I could make somebody a process owner that has no understanding of business processes. That's not going to work. I could make them a process owner and they know what processes are, but they have no tools to influence the performance or the compliance of these processes. That's not going to work either. So when you make somebody an owner of an AI-enabled tool, you have to give them the knowledge and the tools and the authority to affect the deployment decisions and the quality of the tool. Do I think AI will replace doctors in the hospital? No, I don't think so. I think AI replaces tasks, not jobs. That's something important to remember. Most AI systems are good at certain things that make up a fraction of somebody's day job. So if AI is going to automate something, it's going to be components of a task. And that means that the composition of tasks that make up the job is going to shift. Your time is freed up from one thing to take on another thing. Maybe as a doctor, I don't have to spend as much time reviewing images, and I have more time to talk about a patient, about their medical history, or to understand their particular concerns, their particular situation. So I don't think we're going to see completely robotic hospitals, but I do think that the healthcare professions will shift to different job profiles of different task compositions. Some tasks will clearly go to AI, and then there are other tasks that will remain ubiquitously human. If you look at the Mayo Clinic example, the radiologists are still there, they still decide. And then there are new jobs like that governance board that looks as AI as a medical device or software as a medical device. So how do you deal with poor data or the lack of data if you're trying to train an AI system without making it biased? That's an acquisition level problem. And if you don't solve it on the acquisition side, it will cascade through everything else, right? If the data is incomplete or not representative or noisy, every downstream dial is affected by that. The AI will find patterns in whatever data you give it, including patterns that reflect the biases of the original data or how the data was collected. So first, you have to be honest about the data that you have. You cannot really generalize from samples of one or fewer. So if you don't have samples, maybe you need to create synthetic data in order to train the system. So don't treat a model that's been trained on biased data as one that can easily operate at level 7 or 8 of the Sheridan scale. Second, think of the Amazon lesson. The people that train the model on data may have a different perspective on what accuracy means from the people that use the model, the domain experts or people that sit in legal or HR or compliance. Make sure that everybody can take a look at the training process and the training data to uncover potential biases that you as a machine learning engineer or you as a data curator might not be aware of. And the third is if you have a system where you know that the data quality was so-so during the training, build in enough slack during the decision-making phase and the action phase so that you make decisions reversible and that you don't suffer from unintended consequences. Which industries are most mature? Typically those where their acquisition and analysis dials are already very high and the consequences are relatively reversible. So you have financial services, you can claw payments back, you use it for fraud detection or document processing. You have logistics, route optimization, for instance, or demand forecasting. You have manufacturing and quality inspection or predictive maintenance where AI is deployed widely. And you have, of course, customer service, chatbots, triage, routing, the first response to the customer. So what all of these have in common is that the AI handles pattern recognition tasks that are information intensive. And the humans are in the loop for decisions that have significant consequences. So think of JPMorgan's coin example. It's important to distinguish between the AI as mechanism that replaces certain tasks and the displacement of certain jobs. Of course, the composition of jobs that we have is going to change over time. Frankly, a vast majority of the jobs that people have today did not exist in 1946 or 48. right? So we are constantly in a state where jobs get reinvented, get added. 20 years ago, we did not know what a social media influencer was, but here we are. So there will be new jobs that emerge, new compositions of tasks, new requirements of skills that will emerge. But there will be the requirement for retraining and for the acquisition of new skills. So in terms of the displacement, yes, there will be tasks that will be replaced. There will be other tasks that will become more important, and there will be tasks that will be newly entering the workforce and maybe create new jobs. So I think there's going to be more of a need for translators, people that understand how the AI connects to business workflows. And if you're displaced from a routine task, you might be well placed in a translator position or in a curator position because you understand the domain better than anyone. But the challenge is organizational. Does the organization invest in this transition, or do you just cut cost and cut headcount? And that's really the management decision. It's not a technology decision. So there is shareholder pressure, of course, there are management decisions, but if you just cut heads, it might be a short-sighted move. A fundamental limitation of large language models is that they interpret text, or they are trained on text, and they produce output, and they don't have an epistemological foundation to understand which text is true and which text is an opinion, right? So they can't really validate claims in text. For them, a post on Reddit and a Wikipedia article have sort of the same truth value. Now, one of the things that we might do is we might do retrieval augmented generation. So somebody asks the large language model a question, the model goes out to trusted data sources and adds this to the context of the question so the generated answer becomes more reliable. There's also, of course, the role of the user, the role of the human. What do you believe? Is this the kind of claim that's settled or contested? And here I think I see too many people just trust blindly in the output of a chatbot rather than asking, are you sure? Where did you get this information from? Is there anything to substantiate this claim? So that's another argument to keep the decision dial on the lower side of the automation spectrum. If the AI can't distinguish between an established fact and an evolving opinion, the human must provide the judgment. If the automation treats everything as certain, then we're at a higher automation level, but that level may not be what the accuracy of the data warrants. Maltbook and OpenClaw and anonymous AIs posting in a social network and going rogue. It's a science fiction-y scenario, and it's really on the Sheridan scale at level 9 or 10. It's systems talking to systems. The computer decides everything, and there's not even a human invited to the conversation. It's dramatic to frame this as rogue. The risk is a little bit more mundane, right? So when you have agents that interact in a shared environment, you get something called emergent behavior. You get behavior that neither developer of each individual agent could foresee because you get these dynamic interactions. And that's Perrow's theory behind normal accidents, that interactive complexity plus tight coupling plus speed produces failures that are inevitable and unpredictable. You just don't know what's going to happen. So the question isn't what happens when agents go rogue. It's who's accountable when agents collaborating create an effect that neither individually could foresee, that neither was designed to produce. If nobody owns that question or that outcome, then you have a system that is not governed, and accountability is basically removed from the entire system. So, same design principle that we talked about earlier. You match the automation to the reversibility of the consequences. If we're talking about Maltbook, it's agents talking to agents, and there is social media output, and it's essentially a reputational consequence that might follow from this. But if we are talking about, say, high-frequency trading systems trading with other high-frequency trading systems, then you want human governance in that space, because you can get these spirals of reinforcing loops where the system might just spiral out of control, and the consequences are much more severe than a bad mold book post. How do we incorporate AI in teaching? In different ways. So at Stevens, we've incorporated AI in many of our courses, in pretty much all of our curricula. So in the School of Business, we have this course called Management of AI Technologies that is required across our different master's programs. We are also launching a new Business and AI undergraduate major. In certain disciplines, you have AI courses that are more specific, like AI in pharmaceutical manufacturing. And we have AI courses that are on the engineering side. So we, in our data science program, in our machine learning program, in our computer science program. So that's the content question, right? Where does AI show up in the content of our courses? But I also use AI in my course production. For example, if I teach online, I use the transcript of the sessions as well as the transcripts of the chat to compare what was discussed to what I had planned in the syllabus, and to dynamically then adjust what I'm going to talk about in the next session. I can track participation, I can track questions that maybe we didn't get to answer during the class, and I can provide a Q&A afterwards for students to review before the next session. But the pedagogical judgment stays with the instructor, right? I'm not asking Claude to teach a class for me. I'm providing the framework of the course. I'm providing the learning objectives. I'm using the AI to keep track of things that I don't have the bandwidth or capacity to track while I'm focused on teaching a particular concept. So the AI as a teaching assistant can be quite helpful. And that's an area where I'm increasing my own productivity, and I think I'm increasing the quality of the courseware that we deliver. Will we cover AI in B2B go-to-market execution? So this lecture series is 6 lectures. We're going to run another one in the fall and probably next spring again. We do have a lecture that Jordan Sucho talks about AI entrepreneurship. We have one on AI and data. We have one on AI in financial services. So we have a lecture, Katja Megiorin is going to talk about AI business models. So this content is in the series. I would keep a lookout for the announcement of these other talks that are happening Thursdays, 9 a.m. Eastern. And if it's not in this series, we might pick it up in the next series that's happening in the fall. How do we deal with anxiety about AI and reassure human relevance? It's rational to be anxious about AI. If you don't understand how AI is going to affect your role, the default assumption will be that I'm going to be replaced. And the antidote to that is not reassurance, everything will be fine, but it's clarity about what's happening. And so the leadership spectrum gives people an answer to, where do I fit? Are you a technologist? Are you a curator? Are you an integrator? Are you a user? Or are you a manager? So they're distinct roles with distinct skills, and most of them are growing in demand. They're not shrinking. The most effective intervention includes transparent communication about which tasks are being automated and which tasks are being augmented, and investment in reskilling that addresses that certain tasks are migrating from a human to a machine, and other tasks will raise in importance. If you just layer an AI onto an existing organization, you're squeezing certain people out that have a place in the organization due to their expertise or due to their current role. You will have to reorganize with AI in place. You will have to have a new organization. Few organizations have figured out what that's going to look like. And so from the now to the future, what that transition path looks like, that's really the leadership challenge.